All right, so what are we going to be talking about today?
My guess would be the pH calculation.
Right, very good. So if we're calculating pH, what are we going to be trying to figure out? What does it have to do with?
It has to do with your hydrogen ion concentration.
Uh-huh. If I've got a high hydrogen ion concentration, is that an acid or a base?
If it's a really high hydrogen ion concentration, it's going to be an acid.
Right.
So that
Okay.
means the pH would be 0 through 6.
Right. So acids have a pH. I always get those backwards. Lowercase p, capital H, of 0 to 6-ish. 6.5 is still technically an acid. And then, so that's going to have a lot of more H plus ions, more H plus ions than OH minus ions. Okay? So the other end of that is going to be bases. So what the pH do I have if I'm talking about a base?
Well, let's see. 7 is neutral, so I would say between 8 and 14.
Mm-hmm.
And then I'm going to guess it's going to be just the opposite.
Right. I've got fewer.
You have less hydrogen ion concentration than you do hydroxide ion concentration.
Okay. Now is a good time to mention, whenever we're talking about the hydrogen ions, there's another way to say that there's hydrogen ions. And that's because a H plus ion, whatever it gets in with water, it will bond onto the water and make a
Extra H?
OH3 ion, which is water with that extra plus on it, extra hydrogen on it. So these are essentially the same thing, and we're going to use them kind of interchangeably on this practice. Okay?
Sounds good.
So whenever we're doing our hydrogen calculations, okay? So what we do, we do a, what?
So this would be if they give you hydrogen ion concentration, you're
Right.
looking for pH.
Okay, so your pH is going to be equal to the negative log of the,
Which is hydrogen ion
of your hydrogen.
concentration. I'm not gonna lie, looking at this formula, I feel like I've seen that log button on the calculator before. I think this is a bunch of button pushing calculations.
Yeah, it is. It's just a matter of looking on your formula chart and figuring out how to push the right buttons when. It's not complicated at all. So then we have to also calculate the hydroxide calculations, which is the opposite of pH, is the POH.
So if we have a pH scale, can I use a POH value on that, or do I have to figure out what my pH is from my POH to use the pH scale?
There.
That was a lot.
Wait, what? you lost me there. Okay,
All
so your POH and pH you can use one to figure out the other.
Okay, so you have to use the pH value on the pH scale,
Right.
not POH.
Right.
That's what we were getting at.
Yes. Okay, so if you are calculating the OH, the hydroxide concentrations, so your formula is going to be the P of OH is equal to the log of your negative OH.
And I think that's a typo in our notes, guys. If you look at your notes in your cheat sheet, which we need to fix, it's a negative log as well. It's the same thing as the H. It says equals in your notes, and it should be equals a negative. Dang, Mr. Ressman, not sending those packets.
Okay. So, I think the best way to do this is just go ahead and jump into some like practice problems and work a few problems and see what it's like to do them. So, without any further ado, you should have some examples printed in your packet. So I'm going to pull those over here, and you should see these two examples in there. Okay. So it says, what is the pH of a solution if the H plus concentration is 1 times 10 to the negative 6? Okay. So if I'm solving for my pH, I said we do the negative log of your H plus concentration. So all I do is turn on my calculator and take the negative, and where's my log button?
Right here is log, guys.
All right. Negative log, and my H concentration is 1 times 10 to the negative 6.
Ooh, guess what? We could use the E button again, too.
Right. So we type 1, second, EE, and then it's negative 6. Close your parentheses, and you get 6.
All right. That's not that hard at all.
No. So, if you're calculating your pH, you should get a number between 1 and 14.
That was easy.
Yeah.
And it's 6, so it's less than 7, so that would
Right.
mean it's an acid, right?
Yes.
Okay.
All right. So now if I'm calculating the OH of a solution with a PaOH of negative 3.2, all right, so what we've got to do, if we're calculating OH, I look up here, OH is the negative
10 to the negative POH.
OH, okay?
Right. So what that is, for those of you who are in algebra, hopefully, I think you actually should be talking in Algebra 2 about log and antilog right now.
Right.
So if that's the opposite of log, we'd call it the antilog, or we just do the opposite of the log button, which is second log.
So we can do that. Second log, and it's what?
And we have to make sure we put in that little negative in there. It's really teeny tiny, but it's important.
All right, so I'll put my negative in, and we've got a POH of 3.2. And close our parentheses. Oh, what did I do?
Syntax error. Ooh, that's a good error to make. He did this on purpose, little did you know.
Oh, the
we pushed
negative.
the negative and not, or that's a minus button instead of, when you push the minus, it's a little teeny tiny one for the negative versus the big minus one.
There we go.
I think that needs to be in scientific notation. What
It
do you
is.
think?
And to put it in scientific notation, you hit the second button, and then next to it you see Scientific English. Pop over to scientific notation and hit enter.
I love it when the calculator does it for you.
So it's 6.3 times 10 to the negative 4.
All right, and since this has to do with concentration, whoo, this comes back from the unit we just got done doing. Does anybody remember the units for concentration?
It was molarity.
Man, you're so good. You should
All right.
be a teacher.
Okay. So you should try some of the guided practice on your own. Pause the video now and check it out, and we will work them through now. Okay, welcome back. If you paused the video and tried it, great. If not, well, just follow along. Okay, so you're going to have these guided practice problems. It says, what is the H plus concentration with a solution with a pH of 3.2? Okay, so what am I doing with that?
All right, so if they gave us the H plus, or we're looking for a hydrogen ion concentration, and they gave us pH, I think we're going to have to do the anti-log again.
All right. So
we're going to do second log, and then negative.
Negative's important, and
3.2.
3.2. And we get 6.3 times 10 to the negative 4.
Man, that sounds really familiar.
Yeah, sure does. Okay, So now, our second question is, what is the pOH of a solution if its OH concentration is 6.4 times 10 to the negative 9? So this is one of those we're going to use the log, not the negative log, or the...
Ooh, I like these.
Okay, so we take the log of 4.6 second EE is the times 10, and it's negative 9. Close our parentheses. Oh, I forgot. There's a negative. Insert a negative here. It's the negative log. Sorry. Hit enter. And it's in scientific notation, so I'm going to put it in regular, which is flow. And we get 8.337, so we just call that 8.3.
Awesome.
Okay. In your packet, or handed out separate to you guys, you're going to have this little cheat sheet to help you figure out which way you are going. So, if you aren't sure which way to go, like on this one, we went from what is the pOH of this. Okay, so we were given OH minus, and we were going to, was it pOH?
Mm-hmm. pOH.
pOH. So we were going here, so I used the negative log of my OH concentration.
So it's literally telling you the buttons to push.
Right. You just got to plug in the numbers. Okay. We've got a couple more guided practice problems, I think.
And I think there's just one big one, so it goes on to the next page. But on
Oh,
your page,
okay.
it should be all on one,
Right.
hopefully.
So,
I'm going to do that one first.
let's see. Given an H plus concentration of 5.5 to times 10 to the negative 4 molarity, find the following state whether or not the solution is acidic or basic. Okay.
All right, so the first thing I ask you is, what is H plus equal to? Well, there's no math in that one. You just have to
Right.
rewrite it. Literally, it's
right
just
there.
that. It's seeing if you're paying attention.
So it's 5.5 times 10 to the negative 4. Okay? And then, okay, so now I was given my H plus, and I've got to solve my OH minus.
Well, since I have my H plus, could I go ahead and figure out what my pH is?
Sure.
So if you like this little flow chart, guys, this is what it's starting you at, and I want to go this way. So we're just going to do negative log of the number that
Okay.
they gave us.
So negative log, and then our number it gave us was 5.5 times 10 to the negative 4th power. So my pH is 3.25. Okay, so 3.3.
All right.
Okay.
Now, here's the cool thing once we do this.
Mhm.
Because we've got now two circles that we know. So we can either go here and go down to figure out pOH,
Mhm.
or we can go back over here and go down to find OH.
Okay. I like the path on the left. It looks easier.
I agree.
Okay. pH plus pOH equals 14. Okay, so what was our pH?
Our pH was
3.3. So our pH and our pOH have to add up to 14. So that means I take 14 and I subtract 3 point, oh, that's not a point, 3, and I get 10.7.
all right. So that's
That's my
pOH.
pOH. 10.7. Okay. Now I want to use my pOH that I just solved for. pOH is right here. And I'm going to use that to calculate my OH negatives. So it's equal to negative 10, and my negative log of my pOH. So grab my calculator again. and I take my negative log of
And the pOH
H was 10.7. And I get 5.0 times 10 to the 10th power.
And that's my OH concentration. And our very last question says whether it's acidic or basic. This is one of the things we talked about in the last video, where we said, do I use the pH or pOH for the pH scale? So it's pH. You have to use the pH value for your pH scale.
Okay, so my pH is 3.3. So what does that mean? Is it an acid or a base? It's less than 7.
So it's acidic.
Yeah. And that's it.
Not too hard.